In 0.2 seconds, a star can release more energy and neutrinos than our sun will in its entire 10 billion year life. The light show follows later, but the star's core has already undergone its catastrophic collapse. But your average star? It just quietly shrinks and goes dark. What decides which fate a star gets? Every star is a tug of war. Gravity crushes inward. Nuclear fusion, hydrogen smashing into helium, pushes back out. For billions of years, it's a perfect standoff. The moment the fuel runs out, that balance breaks. And here's the key. What a star weighs at birth, measured against our sun, is the single most important number that decides everything. Take our sun. It'll burn through its hydrogen and swell into a red giant, so large it swallows Mercury and Venus. Then it sheds its outer layers like a slow exhale. What's left behind is the core, a hot, dense ember called a white dwarf, roughly the size of Earth, but with half the sun's mass packed inside. It doesn't explode, it just cools for trillions of years. Now take a star 20 times heavier than the sun. It burns so hot and fast it races through its fuel in just a few million years. And it doesn't stop at helium. It keeps fusing carbon, oxygen, neon, silicon. Iron is the trap. Think of nuclear fusion like a money-making machine. Every reaction up to iron pays out energy. Iron, it costs energy to fuse. The machine stops cold. With no outward pressure, gravity wins instantly. The iron core, roughly the size of Earth, collapses to a ball 20 kilometers across in less than a second. That's like crushing something the size of Earth down to a medium-sized city. The collapsing core forms an incredibly dense protoneutron star. Infalling matter rebounds off this core, creating an initial shockwave. But that shockwave alone isn't enough. Here's where it gets wild. A flood of neutrinos, carrying the bulk of the core's energy, re-energizes the shockwave from behind, and together they blast outward through the star at 30,000 kilometers per second. That's a tenth of the speed of light.